Today we're going to start talking about rational expressions, okay? So this is going to be a new subsection of this unit for us. So while we probably will need to remember some of the details about piecewise functions and absolute value functions, these are going to be something that are completely different from those, all right? So before we really get started, we kind of need to know what we're talking about, right? So we are going to be discussing what are called rational expressions. And rational expressions are algebraic expressions, meaning they're going to have variables in them in the form a over b, where b does not equal 0. Okay? So how come b can't equal 0? Well, you'd be dividing by 0. And are you allowed to divide by 0 mathematically? Not so much. So we call those excluded values. Okay, you may also see it written as values that make the rational expression undefined. They mean the same thing. But excluded values are just values that make the denominator equal to 0. Because if it's equal to 0, it's not allowed to. If it's not allowed to, then it's excluded and it's making the rational expression undefined. Okay? Hopefully, you guys all remember that it's very simple to remember why it's called a rational expression, because if we look at just the first four letters, what do we have here? Ratio, okay? A over B is a fraction, but that's also a ratio, okay? So remember that rational expressions are always going to be written in this kind of like fractional notation, and that the value of the denominator can never be equal to 0, right? So next we're going to go take a look at a couple of basic things that we need to remember before we start looking at some other things for rational expressions. So to begin, we have this little example problem, and this is always a fun one to kind of put people up on the spot, because this is a seemingly very, very simple problem, but there are literally dozens of ways that you can make some sort of algebraic mistake when you're doing this, okay? So this would be considered a rational expression, okay? It's some sort of expression, at least it is right now, that's written in the form a over b. So we're going to take a look at the four most common ways that students go through and attempt to answer it and figure out which ways are correct and which ways are incorrect. So if we go and take a look at this, okay, the first student over here recognized that, hey, anytime that you have something divided by itself, isn't that equivalent to 1? I have a 2 in the numerator, I have a 2 in the denominator, so they'll just air quote cancel out, and all I'm left with is a 6. Yay, I'm so good at math. Except, is that how it works? Not so much, okay? So this, totally wrong, okay? Can't do it. Over here, this student looked at it and said, well, 6 plus 2 over 2, well, oh, I remember that anything divided by itself is 1, because remember, canceling, air quotes again here, isn't really a thing. You know, they can reduce to 0, they can become equivalent to 1, and if you multiply by 1, that's the identity property, so I'm going to do that. So 2 divided by 2 is really the same thing as 1, and 6 plus 1 is 7. Yay, I'm so smart, I'm so good at math, except for, meh, that one's wrong too, okay? If we take a look down at the denominator, or sorry, not the denominator, the ones that are on the bottom over here, it looks like this student went and drew like an imaginary set of parentheses. I guess you're allowed to do that. And they said, well, 6 plus 2 is the same thing as 8. And that 8 divided by 2 is 4. Well, you lucky duck. Ding, 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 ding. That works. That is equivalent to 4. Okay? It may seem like this is just an arbitrary, like, how did you know that you could draw parentheses there? Well, if it's over the entire numerator and it's over the entire, or around the entire numerator or around the entire denominator, you can do that. Because remember, what's the first thing that comes in order of operations? Parentheses. Okay? So it means that we really need to go through and simplify everything that's in the numerator and simplify everything that's in the denominator before we start trying to air quote cancel or air quote, reduce and make it equivalent to 1, okay? So we get 4, because 6 plus 2 is 8, and half of 8 is 4. Huzzah! When we go and look at what this fourth student over here did, well, how did we go from 6 and 2 over 2 to just 3 and 1? The short answer is they did 6 divided by 2 plus 2 divided by 2. Okay, so if we wrote that out, it'd be like, well, 6 over 2 plus 2 over 2. Okay, so I'm taking each part of the numerator and dividing it by the denominator and then adding it. Well, if you remember your rules for adding and subtracting rationals, aka fractions, if they have the same denominator, then you just add the numerator. So doesn't this work? Yeah. And half of 6 is 3, and half of 2 is 1, and 3 plus 1 is also 4, which is the same thing we got over here. That's also right, but it's also algebraically defensible, okay? So the big thing that I want you guys to walk away from this is, first, stop saying cancel, okay? That's what this is. It's totally wrong. It's never been right. It's a stupid word. Stop using it, okay? We want to go through and say things that are going to reduce to 1. That's a smart, intelligent, mathematical way to think about the problem, but we can only apply that when it's to everything, okay? And that's where factoring is going to come back into play. That's right, you thought you were done with factoring. Nope, you're never done with factoring. All right, so we're going to go take a look at some examples of how we can simplify rational expressions, identify excluded values, and we're also later going to take a look at multiplying and dividing, but we're not going to get to that part today. So if we take a look at our little guided note sheets, we have example 1 that has part A, part B, and part C in it. And what it's asking us to do is to state the excluded value of x for each rational expression. So we should all remember that rational expressions are written in the form a over b, so long as b, the denominator, does not equal 0. So what I'm going to do is I'm going to identify the denominator in each one of these. So the first one, it's just 3x, and I'm going to make sure that that does not equal 0. So 3x cannot be equal to 0. So if I divide both sides by 3, okay, 3 divided by 3 simplifies to 1, and 1 times x is just x. So x cannot be equal to 0 divided by 3. Well, 0 divided by 3 is just 0. So x cannot be equal to 0. So what is the excluded value for problem A? X cannot be equal to 0. The other way that that may be phrased is, for what values of x is the rational expression undefined? And if you were to answer the question that way, you would say that x equals 0 is the value of x that makes the rational expression undefined, okay? So it's really just kind of notation and how you're writing it. Just pay attention to the directions and you should be able to figure it out. But really, the big takeaway here is the denominator can't be equal to 0, so x can't be equal to 0. If I take a look at the second part in example 1, we've got 4x divided by x plus 5. I'm trying to identify the excluded value. So let's go take a look and identify what my denominator is. And once I've got that denominator, I really just want to make sure that it is not equal to 0. So x plus 5 should not be equal to 0. So I'm going to go and algebraically subtract a 5 from each side. So I'm going to end up with just x over here, and that's not allowed to be equal to negative 5. So x cannot equal negative 5 would be the answer to this question. If it was phrased, for what value of x is the rational expression undefined, I would put x equals negative 5, okay? But whether it's x equals or x does not equal negative 5 really depends on the question that is being asked. So please just make sure you're paying attention to that. For the third one here, we've got a much more complicated looking rational, okay? I'm still trying to go through and just identify the excluded value. And if I'm going to do that, I need to know what the denominator is. The denominator in this problem is x squared, so it's a quadratic, plus 4x minus 12, and that is not allowed to be equal to 0. Well, the first part of the example, we had a monomial denominator, okay? The second part of the first example, we had a binomial denominator, and now I've got a trinomial denominator. So we're trying to give you an example of each one. But hopefully you guys are looking at this and say, oh, it can't be equal to 0. Oh, but there's a 0 on one side and a quadratic on the other. So what can we do? That's right, we can factor it. So are there factors of negative 12 that add up to a positive 4? Sure. Positive 6, negative 2. Factors of x squared, of course, are x and x. So we're going to have x plus 6 times x minus 2, and that can't be equal to 0. So we would say that x can't be equal to negative 6 or positive 2. Either one of those would go through and give me a denominator of 0, which is a big mathematical no-no. So what are the excluded values? For example 1c, x cannot be equal to negative 6 or positive 2. Another way that that question could be asked is you could be asked, what values of x make the rational expression undefined? And then you would say x equals negative 6 and 2, because those are the values that make it undefined. So again, reiterating this, read the directions and answer appropriately. All right, so hopefully we got the hang of the undefined values there. All right, so what we're going to do next is take a look at how to go through and simplify these. So there's going to be a mathematical process that we're going to try and use to simplify. That mathematical process is we want to factor. That's it. The process is factor it. After it's been factored, we can reduce any common factors. Okay, it's very similar to what you guys have already done in elementary school when you were, quote, reducing fractions. So you'd look at something and say, oh, well, 12 over 18. Well, how can I simplify that? Well, maybe you try and identify a common factor. Another way 12 could be written is 6 times 2. So you could express it as 6 times 2. What's another way we could express 18? Well, we could write it as 6 times 3. Do we have a common factor in the numerator and denominator? We sure do. 6 over 6. So 6 over 6 reduces to 1, okay? And what's left? 2/3. So simplifying the expression 12 over 18 into 2 over 3 is the same thought process that we're going to use when we've got variables and algebraic expressions and the like in here, okay? So let's start taking a look at these three that I'll go with example 2. So these are all simplifying, okay? Maybe we'll also go through and identify excluded values, but at the very least, we're going to go through and just simplify, okay? So if I take a look at the first one, I can see the numerator has already been partially factored because it looks like I've got this 5 that's on the outside, okay? Then I have a binomial expression of 3 minus x. In the denominator, I have 5x, which we should realize is really 5 times x. So in the numerator, I have a factor of 5. In the denominator, I have a factor of 5. And 5 divided by 5 reduces to 1, okay? So you can go through and you can cross them out because the multiplicative identity property says that when you multiply something by 1, it doesn't change. Or you could go and do what we did in the example up here and just kind of write a bigger 1. Your choice. So now that those 5s have been factored out, I really just have a 3 minus x over x. Do I have any other common factors that are in the entire numerator and the entire denominator? No, I don't. Okay, but I have an x and an x over here. Yeah, dummy, it doesn't work that way. Okay, that's not how math works. You don't get to make it up as you go along. There's rules here, people. So just because you have an x in the numerator and an x in the denominator does not mean that you can eliminate them. Okay, it does not mean that they will factor themselves out. Okay, because this is not a factor. This is a term in the numerator. Okay, we can't eliminate just like term to term. It's got to be factor to factor. So this represents the simplified version. You may also want to go through, just for practice, put what the excluded value is, okay? And I know by looking at this and recognizing that my original, not the simplified, original, not the simplified, original, the denominator was 5x. So that's kind of like 3x, so x can't be equal to 0. So you can also go and say, let me know what the excluded value is, and that's a good way to go through and practice that, okay? So now let's take a look at the second one that we've got here. So we have 2x squared over x times x plus 5. So in this one, we have it where the numerator is just a monomial term, but the denominator, I have a monomial factor and then a binomial factor. Well, if I can only eliminate factors, I might need to go and do some factoring, okay? So in the numerator, I have 2 times x squared, which is really 2 times x times x. In the denominator, I have an x times, and then a quantity, because it's in parentheses, x plus 5. So do I have any common factors here? Yeah, I've got an x over an x, which I can turn that into just a 1. Using the identity property, 1 times anything is itself. So in the numerator, I have 2 times 1 times x, so that's just 2x. In the denominator, all I have left is this x plus 5, okay? Is there any other factors that I can go through and eliminate? Nope, okay? There's no factor 2 in the denominator. There's no factor of x in the denominator, and there's no x plus 5 term in the numerator. So this is the simplified version, okay? If you wanted to go through and include the excluded values, we would need to go and look at the original, and we would say that the excluded values, we would say that x can't be equal to 0, because 0 times anything is 0. We'd also say that x can't be equal to -5, because -5 plus 5 is 0, and 0 times anything would be 0. So those would be your 2 excluded values for that problem if you needed to list those as well. All right, so now let's go take a look at the third problem that we've got down here. So the third one we have over here is 5x plus 3 over x plus 3. All right, so we're remembering that all we're allowed to eliminate are common factors. So what factors do I have up in the numerator of 5x plus 3? Well, 5 and 3 are relatively prime, so there's no GCF there, and only one of them has an x. So guess what? That can't be written any differently. It's just 5x plus 3. All right, so then in the denominator, we've got an x and we've got a plus 3. Well, there's no common factor there, so x plus 3. So yeah, that's just the answer. It's already in simplest form. Huzzah, okay? Less work for you to do. What's the excluded value going to be? Well, let's look at the original and say what value of x would make the denominator 0. So what plus 3 is 0? Well, -3. Okay, so this problem isn't really a problem at all. It's already been simplified and there's nothing you can do. All right, now just for grins and giggles, what would an idiot say the answer to this problem is? If you're thinking the number 5, you might be able to reason like a mathematically illiterate individual. How would you get 5? You'd look and say, oh, well, gee, here, look at this math. This math real easy. Look, we got plus 3. We got a plus 3. They on top of each other. Bam, bam, they gone. Oh, look, we got x on the top. We got x on the bottom. Oh, that's the same thing. Bam, bam, they gone. All this left is 5. I'm so smart. Except for no, you're not. That's not how math works. And sometimes recognizing what not to do helps us remember what it is that we should be doing. All right, so lastly, we're going to go through and kind of do a few more examples of how to go through and just simplify. So we're going to take a look at these two bad boys right here, and the name of the game is going to be factoring. All right, the 3 examples that we did before, they were kind of already factored or prime, so we couldn't factor them, but these bad boys, oh yeah, we get to go through and factor. So first off, if I look at example 3a, I'm looking and I'm seeing the numerator is 15x, so that's a monomial, can't really factor it. I'm looking at the denominator, that's 5 minus 10x, that's a binomial, so maybe I can factor that. What could I maybe factor out of the bottom? Well, the GCF, 5 and 5, okay? This is just one 5, but this one is two 5s. So if I factor out a 5, I had one of them here, but then two of them here, okay? So then in the numerator, do I have anything that is divisible or has a factor of 5? Well, sure, I could rewrite 15x as 5 times 3x. Okay, it's still equivalent to 15. That's why there's an equal sign here. But now I can say, oh, cool. 5 over 5 is the same thing as 1. Awesome sauce. Okay, maybe I'll make that a little thicker. There we go. Okay, so 5 over 5 is the same thing as 1. And 1 uses the identity property, so 1 times anything is itself. So it's literally just 3x over 1 minus 2x. Okay, no factors that I can take out here, no common factors between 1 and minus 2x, so that is it written in simplest form. Okay, maybe you also want to include the excluded value, so I would just go over here and say, well, so long as x isn't, what, 1/2? Yeah, that sounds about right. Because you'd like subtract 5 and then divide by -10, or you'd, add 2x and then divide by 2. So long as x isn't 1/2, then you're not going to have anything with a 0 in the denominator, and this is going to be the simplified version. If we go take a look at example 3b over here, well, now we got us some quadratics. We got a quadratic trinomial in the numerator and a quadratic binomial in the denominator. But lucky for me, we've done so much factoring this year that this should be a cakewalk. Because you should recognize over here that this is a quadratic trinomial with a leading coefficient of 1. So are there factors of 9 that add up to positive 6? You bet your sweet bippy. 3 and 3. What are factors of the x squared? X and x. So what's this going to turn into? X plus 3 times x plus 3. You can do this in your sleep. Down in the denominator, it's a binomial. Ooh, just two terms, but it's quadratic. But there's a minus sign there, and a perfect square there, and a perfect square there. It's a difference of two perfect squares. Amazing. So we got our little x and x over here, and we got plus 3, and we got a minus 3. So this is going to be x plus 3 times x minus 3. And if I go to simplify this, well, looky there. I got a factor of x plus 3 over a factor of x plus 3. So guess what those two things become? A 1. So all I'm left with is just x plus 3 over x minus 3. But for the excluded values, I would need to go back and say, well, x isn't allowed to be equal to, and can I look at this part? No, I got to look at the original. What would make the original have a denominator of 0? Well, positive 3 or negative 3. So I could put plus or minus 3 right there. And it's kind of important that we remember that because later on when we're doing graphing these types of functions, we're going to need to make sure we know the excluded values because graphically that's going to make one of two things. So it's important that we remember how to go through and do that. All right. So to recap, we're talking about rational expressions, which are really just ratios written in the form a over b so long as b is not equal 0. Anywhere the denominator does equal 0, we call it an excluded value. When we are stating excluded values, we just take the denominator only and set it not equal to 0, and that tells us what the value of x cannot equal. Fun fact, in the event that you have just a constant in the denominator, say like just 3, well, 3 will never be equal to 0. So that would be a case where you would not have any excluded values. So you would just put none, okay? Like 12 over 18, what are the excluded values? None, because the denominator is always going to be 18, or, 3 if it was simplified, but it's always going to be a number that's not 0. So 12 over 18 would not have any excluded values. If we're trying to simplify, then we're really looking to go and identify common factors that can be reduced to 1, and then write all the parts that remain. Sometimes that's easy because we just got monomials or already factored out numerators and denominators. Other times that might be a little bit more challenging where we have to find a GCF, rewrite something to be able to simplify it. We may have to do some quadratic factoring, whether it's got a leading coefficient of 1 or maybe more than 1, if it's a special case like a difference of squares. But you guys should be able to go through and handle anything that is on the assignment that you guys have to go through and do for practice. So let's make sure that you do that, and let's make sure that we're also taking care of business with Delta Math, because a lot of y'all are starting to slack on that. Not making me happy. Okay, so pitter patter.